I like to think of Booleans a little like Venn diagrams, but in 3D space. Here we have two objects, and here is where they cross over. I'll add a Boolean modifier to the object on the right. The default operand type is set to object. So I'll select the blue circle as the object that will create the Boolean. There are three modes you can set the modifier to. They are intersect, union, and difference. Let's rotate into 3D space, where you can see that these circles are actually cylinders. The blue cylinder is still visible here, even though the Boolean operation is set to difference. We'll hide the blue cylinder. Because the blue cylinder is positioned higher than the yellow cylinder, you can see how its form cuts out a piece of the yellow cylinder more clearly. If we set this to intersect, you can see how the shape is defined by the borders of each object. In edit mode, the original cylinder can also be seen. When switching to union, there'll be a little bit of Z fighting between the object that has been selected as the operand and the sum of the meshes. So let's make that invisible to see what is going on. You'll immediately notice that the compound mesh has inherited the material of the original object. Now, because the shading is set to X-ray, you can also see how the topology is redrawn around where the objects intersect. I'll make the blue cylinder visible again. Moving the object around, you can also see that the modifier updates dynamically. I'm going to add the Boolean modifier to this smoothed out cube object, but this time, instead of using an object as the operand type, I'll select collection. I've set up a pre-made collection of spheres called dots. This will cut out the dots on each side of the die when the Boolean is set to difference. I'll hide the cube for the moment and unhide the dots collection. See how each of the spheres is a separate object. There are two options for solvers. Index-based is the default. We've already seen how this results in transferring the material of the original object to the Boolean operation. I'll set the viewport to rendered view so we can see this difference in action. The dots have a different material. I'll hide the dots collection once more and switch the solver option material setting to transfer. Now, whatever is cut out of the original object will use the material of the object or collection of objects. There are two solver settings. So far, we've only seen how it works when set to exact. I'll show you an instance when the setting fast comes in handy. Here, I have this n-gon shape. It's a cookie. You can see this clearly in edit mode. It is not solid. It's just a two-dimensional object with a single face. I have a collection called cutouts, and this has three solid closed objects, which we will use as the Boolean operand. They have been positioned to intersect through the cookie object. I'll hide the collection once more, and I'll add a Boolean modifier to the cookie. I'll change the operand from object to collection, selecting cutouts as the collection. Now, nothing seems to have happened, and this is because of the main difference between the two solver algorithms. The two solvers work in slightly different ways. Fast is obviously the simpler of the two. It uses an overlap threshold based on the distance between the overlapping meshes to calculate what should be included in the operation and what shouldn't. Exact will take slightly longer. And if we have an object that has some other modifiers already added to it, It's perhaps the better option because the geometry that is calculated before a Boolean is even applied might have some unexpected overlapping, self-intersecting, or some holes might have appeared that you were previously not aware of. Let's take this cylinder as an example. It has a solidify modifier on it, and we'll add a Boolean modifier, set it to difference, and use the object I've called holes punch to create the Boolean. If I set the solver to fast, it seems to do an okay job. But now let's adjust the hole punch object. At some point, the Boolean does not perform well. In fact, it can get things completely wrong. And altering the threshold won't solve these errors. If we switch the solver to exact, we seem to have an issue with the Boolean around this part of the mesh. But our options have changed so that we can now account for self-overlap and even holes. Now if we rotate or move the holes punch object, the viewport does lag a little since the exact solver takes more time, but we don't get any of those errors or artifacting as we did before. Sometimes, however, exact will not give you the desired effect, and fast will actually give you a better solution. One final note on the exact solver. Only when the operand type is set to object will you get both self-intersection and hole tolerant options. If the operand type is set to collection, you'll only have the hole tolerant option available.